Come here, fix this.
Oh. Stop messing with it. Did you start it already?
Mm-hmm.
Just leave it alone now. Hold on.
Oh, that's good.
That's good.
Hello, first class AP statistics with the coronavirus going. Okay. Looking for somebody to log in. Let's do it. All right, so I put on the blog the answer key to the problems I asked you all to do. All right, so if you have any questions on those, we'll do those first, and then we'll continue on. We'll start doing the new lesson 6.3, which I'm gonna break it into two parts. Today we're gonna do, after we do these homework problems, we're gonna do, I'm gonna introduce you to binomial random variables. Binomial distribution random variables. Anybody have any questions about the homework? Yes, no? Number 46, cool. Anybody else? Not one. Oh, not I. So you understood how to do every last one of these problems, Helena? Or did you do the problems? 57 and 58. Now we're cooking with some grease. What page? Are you serious? If you did the homework, it doesn't matter. What page it is, the problems that you're more concerned about. If you did the problem, you know what page you're supposed to be looking at. Who is Wuha anyway? Who is that? You shouldn't have to tell them what page to look on. If you did the problem, page doesn't matter. It's the problem that's the most important thing. And no, I can't work problem number 378. Oh, what page is on? Ugh. All right, so we got 46, 47, 57, 58. That's it. And thank you, Marie. And Brianna. Oh, 63. All right, so that's it. Okay. All right, we're going to look at, so we'll start first one, 63. 63. Okay, we already have 63 up here, Marie, on the board. But I got you. All right, that's it. All right. So we're going to go ahead and start with 46. All right, so 4 to 6, you're going to have to, they tell you it's a norm distribution, so let's look at 4 to 6. So if you do 4 to 6, they told you it's a norm distribution. So then you have what, 9.7 ounces. That's your mean. And you had 0.03 ounces was your standard deviation based on your norm distribution. Okay, now, and your sample mean was 9.63. All right. So the problem asks you to do the problem based on the excess. Okay, so that's going to be y. So y would be the excess, excess beyond what was advertised. So you're simply going to do 9.7 minus 9.63. And then that's your expected mean for your data. And your standard deviation is going to remain the same. All right. So with that said, now you can simply work the problem out. Okay. So your equation is going to be y, because you have to do your conversion. So y is going to be, so for every ounce represent was 28.35. grams. So you're going to put your big X here. And the reason why you want to use the big X here, because you're going to use this equation for your mean and your standard deviation. Okay. So what you want to do here is your mean of your y, which is your conversion. So you simply going to do 28.35 times 0.07. And that's going to give you what, 1 point, I'm around this 4 decimal places, 9845. That's going to be your expected mean. And your standard deviation, we're just going to come here and do, so since it's a single term, we could just do the standard deviation of y is simply just going to be 28.35 times 0.03, and the standard deviation for that is going to be, what's that? 0.8505. Okay, we got that. So now remember, and that's for part A. For part B, since we notice a norm curve, it's if part B, we want to find the probability that your y is going to be greater than 3 grams. Okay. All right. So do we understand so far right here? Because I'm trying to write it big enough so everyone can see it, but I need to erase this so I can do part B. So any questions on this problem here, part A for problem number 46? Any questions? Are we good? Yes, no, maybe. Okay. Oh, outstanding. All right. All right. So what we want to do, so I need to erase this. So now we have a new mean and a new standard deviation based on grams, the conversion based on grams. So it's going to be 1.9845, comma 0.8505. Jesus. I need a nap after erasing this board. I taught my honors algebra 2 class, taught them already. All right. So now that we want to find the probability that y is going to be greater than or equal to 3 grams. Since we know we have a norm curve, we're simply going to do the norm distribution. So we need our formula sheet for this. So now we're going to do, so this is our actual data. We're going to standardize it using the z-score, sample mean, population mean, and that should give us around 2 decimal places. So based on our conversion, we have the probability that it's going to occur about 11.7% based on the population data. We're good? Oh, outstanding. All right. So I'm going to move on. So we have 46 out of the way. And by the way, when we're done, for the people that didn't get a chance to watch this, if you just chime in, it's saved. But it would be better if you hear while we're live, and then I can straighten out questions that you may have. Okay. So please come every day, Monday through Friday. Okay. I know my anniversary is Friday, but I might come in for you all and spend the rest of my time with my anniversary. Okay. Yes, Bree, you're that special. Now, all right. So let's look at the next one. We got to look at 50. So let's look at 57. All right, so 57. Also, if you look at 57, let me see, where is it? All right, so 57, when we did the insurance policy for those, okay, what's that? It doesn't matter how long it lasts. We're in class. If we finish up, it's an hour and a half. So if we finish before then, we're done. If somebody have extra questions, we can probably go a little longer, but we're not going that long. So it's okay. What time it is? Let me finish these problems. Okay, so if you do, remember we did the insurance policy. So if everybody has the same insurance policy, that's what problem 57 is saying. So we do 57. You have W is equal to X of 1, individual 1, insurance policy holder, individual 2, policy holder. Now, so what we're going to learn later on in stats, we're introducing this problem to you now because everything's going to converge to the same mean. Okay, now we found that the average was 303 point, what was it? $303.35 when we did the problem for number 14. Okay, so that was introduced you to that the mean is going to be the same because if you think about it, if 2 people paying the same amount of policy on average, or the company's got their profit on average, it's going to be the same number, right? Off each person. So it's 305 plus 303 35 all over 2. So if we do that, wouldn't that just simply give us 303.35? Okay, so that's going to be the expected mean for W. So when we do problems later on, especially chapter 7, when they talk about the mean, the sample mean and the population mean is approximately the same, that's what they mean about this. And this problem is introduction to that. Okay, now we got to find the standard deviation for W. Okay, now again, the error for each problem is exactly the same. But remember, we got to find the variance first, add up all the variance, and then take the square root. We cannot take the square root separately. Okay, so if we do this, so we have W. So we want to find the variance of W. That's simply we're gonna square everything, all the terms in here. So we're gonna do the variance of x1 plus the variance of x2 all over, in this particular case, we're going to do 2 squared. All right. So when you do that, you're going to have basically 2 times 9,700. This is from the previous problem. 57 squared all over 4. Because remember when we did the standard deviation for problem 18, this was the standard deviation based on the insurance policy. This was the mean based on the insurance policy. Okay, so what we're going to do here, cross this out. This is 2. All right. So now we want to find the standard deviation for W. We simply going to take the square root of $9,707.57 squared all over 2. But we know that's simply just going to be $9,707.57 because the square root of this is just this, right? All divided by the square root of 2. So when you do this, it's going to drop down to 6,864.29. Remember, the more you do something, the less error you're going to have in your problem. So this should make sense to you because when we did one policy, the standard deviation was $9,707.57. But if we did a second policy, we did 2 policies instead of 1. Each time, the error in the variability from the mean has to increase. Because remember, the more you do something, the less error you have if you're doing it to be proficient each time. Oh, that's not a problem. Oh, okay. If you look in here, the reason why I multiply by 2, because isn't this 2 on the bottom? So you're squaring x of 1, you're squaring x of 2, you also have to square 2. So what's 2 squared? It's 4, isn't it? Oh, you can double it because look, Brianna. Okay, so these are the same policies. So they're gonna have the same average amount that the company's gonna make a profit of, right? So you're just gonna simply add these 2. So if you add them, it's just 2 of them, isn't it? Then for this one, you got the variance, you got the square everything. All right, poor guy here. So for 57, that's 57. All right, now what you said, Marie, which part of it? Which one you want to do? Okay. Oh, cool. That it makes sense. Okay. B part of 56? Yes, Marie, I do B part of 56. That's not a problem. Let me go back to it. Did we do 56? Oh, she said the B part of 46? Okay, she said do the B part of 56. I don't think I did. Did I give y'all 56? Oh, yeah, I did 56. Okay, challenge, find the probability of the random selected. Okay, for 56, where's 56? Oh, all right. So what you want to do? You said the B part of 56. You said the B part of 56. So let me look at that part, Marie. I will have to show you 56. I have to show that tomorrow. I have to work it out. I don't think I didn't do 56. That's why it wasn't cut off. I just didn't do it. But I do it. I have it tomorrow though. I promise. Okay, now what was the other one we have to do? We just did 57 and we could do 58. Okay. All right, so I'm gonna go ahead and erase this one. Okay. So let's just say we have 57 to do now. Okay, so let's look at 57. Oh, I did 57. 58. I'm sorry, 58. So 58 is the same principle. Okay, so 58, you have V is going to be, you have 4 policies. All over 4. All right, so the mean is going to be exactly the same. Because remember, your mean of X is equal to 303.35. Your standard deviation for X is going to be $9,707.57. Okay. All right, now, so if you're looking for the mean of V, that's simply going to be, you add this up 4 times. So that's 4 times 303.35 all over 4, which is simply going to give you 303.35. So it's going to stay the same. Now, to find your standard deviation, it should be smaller. First, you got to find your variance. So all these going to be exactly the same. So basically what you're doing is doing 9,707, 57, okay, squared, but you're doing it 4 times. So I'm just going to do 4 here. But remember, you got this 4 on the bottom, so that's 4 squared. So then now that's going to be 16, right? So then that will be 1 because 4 is 1/4 of 16. So that'll be 9,707.57 squared all over 4. So that's going to give you, if I take the square root of that, which is basically going to be 9,707.57 divided by 2, which should give you $4,853.79. Today, 9.63 today. Look, man, let's focus on my math. I don't even know what Nike mean. These side conversations, we're not in class. Okay, now, so any questions on number 58? Oh, let me get out your way. Okay, so any questions on 58? Come on, man. Will y'all focus? We did 57 already. All right. If you did not was not here for 57, you can replay this. Okay, I want to get this done. All right, so let's look at 58. I mean, not 58. It's to get 63 out taken care of. All right, so we'll go ahead and do 63. All right, So 63, you have, so you do 63, you have what? You have four people that's swimming. Okay, so what you want to do, you want the total for all of them. You want the mean, and it's, remember the other day, Marie, when you was asking me, how do you find the standard deviation? Okay, so what we want to do is we're going to look at 63. So we got to do the total. So what I did was the first person was Wendy. So I let Wendy be W. The second person was Jill. I let Jill be J. The third person was Cameron. So I let Cameron be C. And then the last person was Latrice. So I let that be L. So we got to find a total. We got to find a total mean and the total standard deviation for this. So if you're looking for the mean, you simply going to just add. So the mean of T, in this case, W was what? Was 55.2. Wendy was 55.2. And Jill was 58. That was her finish time, 58 seconds. Okay, and then Carmen was 56.3, and Latrice was 54.7. So you're just gonna add that up, and you're gonna get 24.2 seconds. That's everybody's time. Now we got to find the standard deviation for the total times. So what we got to do, we got to find the variance for each one, add it, and then take the square root, and that's how we find it. So for Wendy, the standard deviation was 2.8. We're gonna find, so let's do this. We're gonna do the variance of Wendy plus the variance of Jill plus the variance of Carmen plus the variance of Latrice. All right, so then now that's going to give us 2.8 squared plus, what was that, 3 squared plus what, 2.6 squared and plus 2.7 squared. All right, so that's the variance. All right, so the variance is going to be for the total of all four. So that's going to give us 30.89. But remember, that's the variance. But we want the standard deviation. So we're going to take the square root of that. So the variance for the total is going to be the square root of 30.89, which is going to give us approximately 5.5579. All right. So they said it was normal distribution. So the norm for what we just found was what? 224.2 seconds with the for the total of everyone with a variance of 5.5579 seconds. So I have to erase this because we want the probability that the total time is going to be less than 220 seconds. Can we take what? Can't we go to lunch? We're not in no classroom. Are you serious? What am I do with y'all, man? Eat before you get on the screen. So this is, you know what? You're at home. Just eat. Sit down and eat. And watch the screen. I'm with you, Isaiah. You got to be kidding me, man. All right, so we found the mean and the standard deviation. So now we got to find the probability that is going to be less than 200 or less than 220 seconds. For the love of God, can we eat lunch? I'm in my kitchen. You know what? I'm gonna get me something to eat. What? Eat you something. Put something in your hand. Okay. So you know what? I'm gonna sit there and watch what's real. I'm gonna eat. It's lunchtime. That's how it works. Okay. Everybody got their lanyards. Oh my God. So we got to find the probability of all four total time. The probability, because remember, this is based on the population of each one of them, right? So now we got to find the probability that T is going to be less than 220 seconds. So ideally, we want to better our time, right? Because the average time is 220. We want to cut these 4 seconds off. Well, we won't cut off more than 4 seconds. So what you want to use, this is a norm curve. We're going to use the z-score. Can't we go to lunch? All right, so what we're going to do now, so when we saw that, we should get a negative 0.76. Remember, we look at our z-score table, we're only around 2 decimal places. Okay, so with that number, okay, we're going to get 0.2236. So the probability that's going to occur is about 22.36 seconds. All right, questions? Make sense? All right. Okay. All right. So make sense? Okay, Marquise, trying to get to 3/4 of the page. I'm proud of you, boy. Okay, Marie, if you want to know what the answer is for 56, and I can work it out again first thing tomorrow, it's going to be 0.15. 0.15 is the answer for 56B. All right, so any more questions on this last section? Okay, I tell you what, we're gonna take a 5-minute break so Sydney can eat something. Yes, I have a parakeet. I'm in my kitchen. So, you know, if I get hungry, I can get him something to eat. What is he then? Well, cockatiel. I'm sorry. I have a cockatiel. His name is Ash. Matter of fact, I'm right by my pantry. Let me get me some out of this pantry so I can eat. So if you have your book, please have your book when you come to when you come to the session. Okay, so we're gonna go ahead and get started, and we'll go. So go to page 383. I'm not gonna show you Ash. I have to adjust my computer. He'll probably come fly on my shoulder in a minute. Ash, come here. You want to get on my shoulder? Been in there all day. You get some popcorn? Oh, so you have four things when you're doing a binomial distribution. So on page 383, look in that green box. And so those are four rules for a binomial distribution. We're not going to do geometric distribution because I have to show you how to do some stuff in the calculator. And I don't want to try to do it for both today because I don't want nobody confused. All right, so when you do your binomial distribution, there's Ash. Okay. Yes, I'm on 6-3 now. So, whoa, then yeah, you're a mess. Okay, now, all right. So when you do a binomial distribution, it's four rules. I'm bold. All right. So when you have a binomial distribution, this is or. It should be or. Okay, you have a success or a failure. And your samples have to be independent of each other, and it's a fixed number. Okay. And then you have all samples have the same probability of occurring. All right. So those are your four rules. These are the same rules for geometric distribution. Only difference with geometric and binomial, geometric, it doesn't count until you get a success. Yeah, the bird is just flying. What about? Don't you have pets at home? Don't your pet walk around? Okay, don't they get on the bed? Don't they get on the couch? You got to be kidding me. Let's get back to this work. All right, so these are your four rules for binomial distribution. Got my wife over here about to pee in her clothes because she's laughing so hard. Now, All right. So when you have a binomial distribution, okay, so when you have a binomial distribution, look, man. Oh God, my wife is not gonna get on this screen. Can we just work? All right. So when you have a binomial distribution, the cool thing about for the love of God, Janelle, come here. So these kids, so they can focus. Come here. Quick wave hand. Come here. Because it'll be 4 o'clock before I finish. Now, all right, now. So, well, you know what? She'll be nice and made up tomorrow. You can see her tomorrow, I promise. Now, all right, so what we're gonna do, so you got the binomial distribution. The cool thing about binomial distribution, you can use the norm curve. Yeah, I feel the same way, Bree. Now, all right, so with this, it's pretty cool because with the binomial distribution, you can go straight to a norm curve. So you could use a binomial distribution to approximate that use a norm curve. But what I need to show you first, I need you to go to page 387, and we're going to talk about the binomial coefficient. And please make sure your calculator is charged because we're going to need it. All right, so I think when using Miss Garcia, she kind of introduced you to this. Okay, so this is N choose K. And what you want to do, what that is N factorial all over. Don't panic, I got this. Okay, so this would be K factorial. And then this is going to be N minus K factorial. So what factorial means, this just, if I do 5 factorial, this is going to be 5 times 4 times 3 times 2 times 1. If I had 7 factorial, that means it's going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay? So we get it now? All right. So all right. Thank you. All right. Well, again, we're on page 387. So this is your binomial. This is your binomial coefficient. This is part of your binomial, individual binomial distribution formula. Okay. So this here is read as N choose K. This is your total sample, and this is your part. So in other words, okay, they have, so this is what you would do for here. Okay, so this was anything because your sample size is 20, your K can be from 0 up to 20. And by the way, your binomial distribution starts at 0. All right, it's going to start at 0. Okay, so when you do a binomial distribution, it's a discrete it's a discrete random variable when you make a chart of it. But if you got a circuit condition for that binomial distribution, you will be able to do the norm curve, and it's a way you can make it. Okay, I'm sorry, I just fixed the camera. We're good now. All right, good to see you there, Wanderer. Now, okay, so this is the formula for a binomial distribution. I mean, for a coefficient, this is the binomial coefficient for a binomial distribution. So with this formula, you have an example in the book, and they have 5 choose 5, choose 2. So basically what they're doing here, if you have 5, choose 2, you're just going to do 5 factorial all over 2 factorial times 5 minus 2 factorial. So then that's going to be 5 factorial. Then this will be 2 factorial times 3 factorial. So if I was you, the easy way to do this would be 5 times 4 times 3 factorial all over 2 factorial over 3 factorial. And that way your 3 factorials will divide out. So we know that 5 times 4 is 20. 20 divided by 2 is 10. Any questions? All right. So this is how you perform the binomial coefficient. Okay, so you see how this number is 10? Okay, so what I need you to do is get your calculator out. Okay. And I need you to go to menu and go to probability. Okay. So it should look like this. Probability. Okay, now you want to go out and go to combination. So you go to probability and you should go to go out to combination. And then you want to hit enter. Then you should get NCR. Now put in that parentheses 5 and 5 comma 2. And once you do that, you can go ahead and hit enter, and you should see that you're going to get 10. Got it? If you have a TI-84, you can go to your menu and you can find probability as well. Okay, so if you have a TI, if you have an Inspire, you're going to go to menu and you're going to go to menu and you're going to go down to probability. You can find your probability screen as well in your TI-84. Once you see probability, you're going to press to the right, and then you look for combination. You did this in Miss Garcia class. Then you're going to hit enter. Then you're going to have N. You have N capital CR. You're going to put in there 5 comma 2. Then you're going to hit enter and you should get 10. Put 5 comma 2, Bree. Oh, if you have an 84, if I remember correctly, you have to do 5, then go to probability, then go to combination, and then hit 2, and then hit enter. And that should give you 10. Did it work, Bree? Or the people with the 84s? You don't have to do a comma if you got 84. Outstanding. Good job. All right. We're good there, Sydney. Okay. You don't need to go get that to eat, do you? It's lunchtime. Okay, good. Damn, what do you have? Don't you have an Inspire? That's fine. Get you some coffee. It's fine with me. All right, so okay. All right, so Danielle, is that for 84 or is for Inspire? Which one do you have, Danielle? Okay, good. Okay. Okay, 10 represent how many times you're gonna do it. Now we're gonna use that's the first part of a binomial distribution formula. Okay, so look, man, y'all killing with these side conversations. Just you know what? I'm gonna turn off this thing and let you all teach each other. Because I would like to move on. Now, Thelma, I need you listening because don't you ask me again. Okay, now go to page 388. Go to page 388. Now, on 388, that's your individual binomial distribution. You cannot do several of them. You can, but it'll take too long. That's why you need your calculator, your graphing calculator. You will not be able to do this chapter without a calculator. Okay, now, so I'm going to erase this and put the whole formula for binomial distribution up here. All right, now, so I just broke down this. So for binomial distribution, again, you got success or failure. And all the probable, all for each individual has to have to be independent of each other. In other words, one should not depend on the other in the sample space. Now, it has to be a fixed number. So if you start, if I tell you that you can do a retest once, that does not mean that you can keep taking the test until you pass. You can only take it one and one time only. That's a fixed number. Okay. And then all of them should have the same probability of occurring. Just like when you walk in my class, everybody should have the same probability of getting an A in the class, right? But that's not always the case. So if you break this down, this is what you're looking for, probably what you're looking for. This is your sample size. This is what you're looking for based on your sample size. P is always your success. I put Q here because when you get to college, they're not going to say 1 minus P. They're going to say Q most of the time. Now, then you're going to have N minus K, right? So I put here Q is 1 minus P. That's the failure. Okay, so P is going to be your success. Then K is what success you're trying to find based on the probability of all being the same. Okay, any questions? Oh, I'm sorry. I don't know why it's delayed. All right, so just not deal with it, but I'm sorry, but it should be delayed though. It really should. Okay, so these are all the things that you need for your individual probability. Now, with this, now I'm gonna show. Now what we're gonna do is we're gonna do a problem. I'm gonna do a problem. Then I'm gonna let you do a problem, and so you can give me the answer. So is this? Owen, why are you on here? All right. So now I have to erase this. All right. So what we're gonna do, if you look at so I'm gonna do a problem right quick. So I have to erase this, but just remember this is the problem. Okay. So what we're gonna do, I'm gonna erase this right here. So we have a sample size, a fixed number. So we're gonna do 6. And the probability is going to be 0.3. All right. So what we want to do is we're going to find the individual probability. So we're going to find the probability that X is going to be 4. Okay. So this 6 is going to represent N. So we got a fixed number of 6. And so we're going to say that have success and a failure. Okay, all 6 of these samples are independent of each other. Okay, they all have the same probability of occurring, which is going to be 0.3. Then we're going to find the individual probability for 4. So what we're going to do here, okay, we're going to do N. So we're going to do 6, choose 4. Then our success is going to be 4, right? So, but our success is going to be 0.3. I'm sorry, 0.3. And we're looking for it's going to occur at 4. Then we're going to do 0.7, and 6 minus 4 is equal to 2, right? So now we have 6, choose 4, times 0.3 raised to the 4th times 0.7 raised to the second. Now, Before we do any math, if you notice that our sample size is 6, right? If you look in the exponents, 4 plus 2 is 6. So these two is always going to equal to what your total is. If you look down here, 0.3 and 0.7 equals to 1. So that means we have the entire sample space. Okay? So now in your calculator, we can find the combination of 6 choose 4. So I showed you how to do that. So go ahead and do that. So we're gonna do menu. We can go to combination probability, go to combination, and we can do 6, comma, what's that, 4? Okay, and then that's gonna give us 15. So we have 15 times 0.3 raised to the 4th times 0.7 raised to the 2nd. Then we put that in the calculator, and that'll give us the probability that success is going to be the 4th try. And that should be a prop. So that's going to be 0.0595. So that's going to be about 5.95%. Or you can say 6. Thelma, Q. Remember we said Q was 1 minus. We said Q was 1 minus P. So that's 1 minus 0.3. It's going to give us 0.7. So we get it now? All right. Okay, so now I'm going to give you all a problem. So I want you to take this same problem and I want you to find, I'm going to erase this. Now I want you to find X is equal to 3. All right. When you're done, somebody put the answer up here to see if you did it right. Waiting for an answer. Where are you there, Kendra? Or Abina? Oh, look at you, Angela. Outstanding. Good job. Okay. Outstanding. But just round 4 decimal places, okay? But that's the right answer. All right, so I'm gonna put it up here. So what we're gonna do, so we had to do 6 choose 3, then times the probability of your success, which is 0.3, raised to 3, times your failure, which is 0.7, raised to the 3. Again, these two exponents have to equal your sample size, and then your bases have to equal to 1. So now when you put in 6 choose 3, you should have gotten 20. Then you want to do times 0.3 raised to the third times 0.7 raised to the third. Then you round to 4 decimal places. So that's 0.1852. Oh my God. Can we round? We've been rounding 4 places to day 1. Okay, thanks. Whew. All right. Now that we know how to do that. Okay, so let's say we had to find the probability. So everybody got that right? Okay, we're good? Yeah, but we know that's 4 decimal places. That's why I've been doing it, to get you ready for this now. All right, so we're going to move on. Okay. All right, so what I want you to do, I'm going to show you how to find this, because that's just for individuals. Okay, so now we're going to find the probability that X is going to be less than or equal to 3. So what that means is, since this is your probability, you have to find a probability X is equal to 0, because this is your failure, plus X is equal to 1, plus X is equal to 2, plus X is equal to 3. All right? And so when we add that up, that's going to be the answer. But you could do that, but that's a lot of work. Okay. So what I need you to do, if you have a Inspire, I'm going to inspire you. All right, now, so what you want to do, turn your calculator on. All right, so what I want you to do is go to menu and go to statistics, and then go down to distributions. So your screen should look like this. So go to statistics and then go to distributions. All right, so if you have a TI at 4, let me see, how about you go to distributions? Let me think. I think it's in the book how to do it. To go to distributions. I think it's stats. I think you go to stats and go to distribution. I think you can. Okay. Well, if you have your Inspire, it looks like this. So you got distributions. Now you're going to scroll over, but you want to scroll up until you see binomial CDF. Not binomial CDF. So it should look like this. Where is it? Binomial CDF. Okay, so once you hit enter, Then you're going to have your number of trials, which is, in this case, is going to be 6. So you type in 6. If you notice, this starts at 0. So when you do a binomial distribution, it's always going to start at 0. All right. Okay, then we want the probability of success is 0.3. So 0.3 goes here with your probability of success. And then you have a boundary. Okay, so remember we said x is less than or equal to 3, so it's 0 was the lowest outcome. Okay, now what you want to do here, you want to go down and hit 3. So what you did was here, you got your sample size, success, your lower bound, and your upper bound. Now you're going to hit OK. What I do? Oh, let me see what I did. Now, then your probability, your cumulative probability should be 9 to what I put on the board. Okay, so it should be 0.9295 if you round it 2 decimal places. All right, so what was it? Yes, it is. Okay, so if you have, who said they got an error? So what's your question? Miss Goodman, get off my screen. How do we have to do it individually? Let me see. What you can do, Brianna, because I don't have a TI, I don't have a hold on, let me see. Let's see, do I have a TI-84 here? Let me look. Hold on for a second. Hold on, I got to run the garage. I gotta get another face. Hey, Brianna, you're gonna have to do it individually. I have to, or you can look up how to do it. Because I have to. You can go on the internet and it'll show you how to do it. Because Bryce takes it. I forgot he's taking an economic class, so 84 I bought him. He took it back to school with him. Oh yeah, that's it. You have to do. Okay, somebody. So Jennifer, you know how to do it. Thank you. Oh yeah, it's on page 389. I forgot it was in the book. It's on page 389, just like Jennifer said. Got it? Okay, that's how you would do that one. Okay, so what I have to show you now is how, because when you do a chart, when you do your binomial distribution, we're going to do a individual, we're going to find the individual probabilities. Okay, so what you want to do, I'm going to show you how to do that so you can make a chart, because you're going to have to do that on the test. All right, so if you have a Inspire or 84, I'll say go to your table screen. Okay, so we're gonna make a table. All right, so what we're gonna do here, I'm gonna find the individual probability. So since this sample size is 6, So let me erase this. So we're going to make a chart. So we said that n was equal to 6. We said that p is equal to 0.3. All right, so we're going to do a table. We're going to find individual probabilities. So we're going to do our outcomes. And we're going to do a probability assigned to each outcome. Being as a binomial, success or failure, independent fixed sample size. All the sample size have the same probability occurring. Okay, those are 4 rules. So now we got to do x is equal to 0 because 0 represents that you have all are failures. You got x is equal to 1. You got x is equal to 2. X is equal to 3. Up to x is equal to 6. So I ran out of space. Okay, x is equal to 6. Well, you know what? I'll rewrite it so we can get all 6 in there. That's not a problem. Because it's cool that you could do the cumulative and it give you one answer, but we need to do it where you have the individuals. Okay, so we got to find for each outcome is assign a probability. All the probabilities have to be between 0 and 1, and we add up is equal to 1. Okay, so what you want to do now is go make your table, go to your table. So I'm gonna name this table success. Okay, so I'm gonna put success in the top. But if you got a 84, you just list 1. Hey Jennifer. No, well, I'm doing my online teaching, so I'm going to call you back. Yeah, I got a class of 21. Okay, all right. So I'm gonna put success in here. So you know what? Just put SUC. We're gonna put success now in that column, which is list 1 for you all. Put 0 through 6. 0, 1, 2, 3, 4, 5, 6. Okay, now we want to go up to, we got to go in comma 2. We're going to put the probabilities. So I'm going to put P S U C. All right. So that's what I did right here. These are my successes. This is my probability success based on the sample size being 6, with my success being 3 for each one before I do my calculations. All right. Now, so if you have a 84, what you want to do, if you have 84, you got to do your, how can I do this? Well, you got to do your individual probabilities. But if you have a inspire, you're going to go to, so you're going to hit enter. And you got your, remember on the bottom, you got the equal sign. So what you want to do is you want to go to menu, go to statistics, and go to statistical, and go to distributions, go to binomial distributions. But what you want to do, you got a CDF and a PDF. CDF is cumulative. PDF is individual. So then you want to click on that. Binomial PDF. Then your number tries is 6. Your probability is 0.3. Then for your X value, you're going to put in success. So you have SUC. Okay. Then you want to hit OK. Then you want to hit enter. So when you do that, those are your individual probabilities. So if I fill this chart in, the probability of getting a 0 is going to be 0.1176. Probability of getting 1 is 0.302. And then you should have the last one for 6. You can fill that in. Is 0.0007. Now, if you know how to do binomial, okay, now if you have the binomial distribution 84, what you can do is you can go to, you know how you found your distribution for your binomial distribution? So what you can do is for your TI-84, you can, instead of putting that number at the end, I think it's at the end when you're doing a TI-84, instead of putting a number in there, you're going to put list 1. And you're going to store that in list 3. And I'm sorry, list 2, I'm sorry. List 2, and you should get the same thing. Again, if you have 84, how you found the individual binomial distribution, the cumulative, which was CDF, you want to do the PDF. PDF is individual. So instead of putting that individual number in, you want to put list 1. Then you're going to store that in list 2, and you should get the exact same thing. Okay. All right, cool. Okay, 84 got it. Outstanding. Okay, we're cooking with some grease. What time is it? But when they ask for binomial distributions, just don't do that part. So I'm going to show you how to find, use a norm curve with a binomial distribution tomorrow. And I'm going to show you how to do geometric distributions tomorrow. Okay. All right, so just do your homework on the blog, but the part that talk about norm distributions, just forget about that. Then I'll show you how to do it tomorrow, and I will show you how to do the geometric distributions. Okay. All right. So I'm going to sign off, and make sure you eat your lunch tomorrow. If you don't have it eaten, okay. What page is the homework? It's on the blog. I sent y'all a reminder yesterday that told you the work is on the blog. You gotta be kidding me, man. You have to be kidding me. I just said go on the blog and do the work. Just don't do the part. Thank you. I appreciate it. Okay. All right. See y'all later. Quit getting on my nerve.